Hey guys! Welcome to part 3 of the Complex Road series. In this tutorial we will combine what we did in the previous 2 tutorials. If you don't have the files, don't worry, there's a link in the description to the scene file, which has what you need to complete this tutorial. In the end we will import the tool into Unreal, so it's recommended to have Unreal with Houdini engine installed. Let's go! We will start by creating a geometry node and copying over our intersection solver. And we will copy over our asset. So, now we've merged them. In this video we will be merging these two assets together. We will make an intersection solver that also creates geometry. Our asset basically uses two different inputs. One is a middle line it uses to sweep the road, and the other one is the outer lines of the road, which it uses to place down the railing and whatever prop you might want to be in that place. Now, our intersection solver already provides us with the mesh of the road, so we don't need to worry about that one, but we still would need to have a middle line, and we need to have the outer lines. The outer lines are the most important, and we're going to focus on those right now. So let's dive into our intersection solver. And first, do not forget to make the other ones invisible. That's only going to be annoying. When we dive into our intersection solver, we can see that we have the outer line already, but we're deleting it, and now we want to keep it. So let's place down a merge and two group nodes. The first group is going to be the intersection mesh, and the second group is going to be the outer lines. Now over here we can see that we have selected the outer line. Let's throw it into group 2 in the outer line group, and our original mesh needs to be wired into the first group. Then we can merge those together and put them into the repeat end. Now we need to separate them again, so place down a blast and select our outer line group, delete not selected, and you can see we have the outer lines of our intersection. And for our original mesh we need to do the same thing. Let's copy over the blast and let's delete selected, and we have our original mesh. At this moment we also need the outer lines of the rest of the road, so let's get those. You can see at the first delete we are only keeping the part we need for the intersection, and we want to keep the opposite of that. So let's copy over this delete and let's set it to delete non-selected. So we already have a good part of the intersection, but we don't have everything yet, because we're also removing a part with the carve over here, our custom carve function. So we also need to reverse this one. To do this, let's copy these two over. First we will make sure that our length value will not exceed the length of the parameter. So if we're going to look at our primitives, we have our parameter and we have a length value. And right now we are making sure that the length value won't be longer than the parameter. Now we need the remaining length. So we're going to take the parameter and we're going to subtract the length. And we're also going to place a reverse. So as you can see, this is our original curve. And here we have the length of our intersection, and here we have the opposite. Now we can merge these two together. And now we have all of the road that is not part of the intersection. Now let's fuse these together so they become one nice line again. Then I want to have the length attribute and the width attribute. I want those to be on the points. So let's grab an attribute promote. And I take the primitive, select the width and the length. Now those are also on our points. Now we're going to clean up our line again. So place down a convert line. You don't always have to do this, but it's quite handy. You could have a very difficult input, and it's just a way to clean it up. So you place down a convert line, you place down a polypath, and you also place down a polyframe. With this polyframe, we're going to do the same thing as last time. Set the tangent name to n. Place down a point fob. And with this point fob, we are going to offset our curve. And we're going to use the normal and a cross product for this again. So place down a cross product. Wire in our normal. The second normal is going to be up factor. That's already good. Then place down a bind. We will be needing our width value. And let's multiply these two together. Now let's place an add node. Add these two together with the position that it already has. And you can see we have offset our line. We're going to do this the same thing for the other side. So let's just copy this over. Place a multiply constant. Place this in between the width and the multiply. And set it to -1. And merge these two together. So that's already looking better. As you can see over here, we have a little error over there, and that's because our initial resample is just as a very high value, which makes it very inaccurate. So let's crank this one down a little bit, and that's perfectly fine. Alright, now these are the outer lines of our normal road, and we're going to merge these with the outer lines of our intersection to see how they fit together. Now, as you will see, there is a small basically error over here. I wouldn't really call it an error that much, but it's basically because our our end normal from this point is different from the normal you can find on our intersection point. It's just slightly different because in our code we're selecting it in a different way. But right now it doesn't matter that much. They're very close together, so let's just place down a fuse and let's merge those two together. Alright, so there we go. Here we have the outer lines of our intersection. So these are almost ready. The only thing they really need is to be cleaned up a little bit because they've been generated in different orders, they have different directions, different attributes a little bit, so that's a little bit messy. So let's just clean them up the same way we always do. I will first place the convert line again. Probably not even needed, but it doesn't matter that much. We can later test if it's needed or not. And then we are going to place down a polypath. Place down a polyframe. And let's do the same thing again. Check out the normal. Tangent name is going to be the normal. There we go. And well, that's it. Now we have our initial line again. Let's place an output node over here. So a null node, but I'm gonna call it out. And I'm gonna call this and color this. So the color red, because I like the color red. I use the color red usually for my output nodes. And let's write this out. Outer lines. Alright. Now, right now we're going to throw this into the system. So we have multiple things that could need this, and right now mainly our railing needs it. So we are going to exchange these two. I also know that these three are actually essentially the same. So let's delete two of them and basically use one for all. Now we have our object merge selected. let's drag our output node in there. Alright, and let's have a look at this result. So our scaling is a little bit off, and I see that we don't have an up attribute yet. So let's add the up attribute. Place it down a point triangle. And let's write add up.y equals 1. That fixes some of the orientation problems. And now let's mess a little bit with the scale of our intersection. While I'm adjusting the scale a little bit to make it look a little bit better, and so we have a clear overview, I'm going to talk a lot about what we're going to do next. We're going to implement the pillars and the road paving. After that, we will merge everything together into a digital asset, an HDA, and this asset is what we will be using inside of Unreal. You will finally have a working tool in your game engine. Alright, there we go. So here you can see what I love about Houdini. Everything just follows the curve, and that is so nice about it. You can have a different input, and everything is so modular, you can iterate upon it. It's really the power of Houdini, and I just love it. Alright, so now we also need the middle line of our curve for the support pillars and so on. And we can basically get it out this initial polyframe. So now we know, let's place another point triangle and make sure it has an up attribute. So add up.y equals 1. And let's place another null node and declare that our output node. So at first our road paving will be needing this middle line. So that will be this object merge. And we have our pillars, which also need this. So these two are also the same. So let's just delete this one. And make sure the inputs are correct again. And now select the object merge and select our output node again. Throw it in there. Oh, I made a little mistake there, because this one is the output for the curve pillar. And that's of course a little bit different because we also did a height calculation. So this object merge should have the input. Alright. And let's look at our final merge. So let's look at our final merge, and that's already looking pretty good. We are missing the intersection, and that is because we are not using our intersection yet. So let's throw it in there. I don't want to use the UV quick shade. I'm just gonna drag this in there right now. A little bit dirty, but well, yeah, it's fine. So that's already almost perfect. We are having some normal issues because not everything has normals yet before we throw it in there. For now, I'm just going to use a normal node at the end of the merge, so everything is normals, just to see the quick result. So now, if we would be dragging up one of our curves, you will be able to see the pillars. And there you go. Pillars are still fully functional. So we've successfully combined our two assets, and what we now want to do is to combine this into one digital asset we can use inside of Unreal. To do this, it's not very hard. There's one thing you need to keep in mind, and that is that our object merges usually, because we just drag it in there, they don't have a relative path, but they have an object path that starts at the OBJ level. This is usually not what you want. It's safer to do this manually. But I know that if I'm going to create a digital asset out of this entire system, excluding the curves of course, and I put this in a subnet. Okay, make sure that you think about one thing, and that is that we used an objective path over here, and that's not what we want. So we're just going to make sure that every object merge of us has a relative path. Because we're going to use an HDA, and when you're using an HDA, always use a relative path. unless you're referring to a certain file or anything, because otherwise it usually gets very messy very quickly. So I think we have everything. Now let's create our HTA. But first, let's place one more merge, and let's make sure that our HTA knows how to handle 4 inputs. You could make this as many as you want, but for now I'm going to use 4 because it's easy. And let's go to our subnet. Right click the subnet and let's create a digital asset. Now this digital asset, we can well, save it where you want to save it. I have my own personal HTA folder, and I'm going to create a new folder in here called complex roads. And I'm going to call my HTA a road tool. Nice and generic. Let's change this to road tool. And hit accept. Oh, it seems I've missed one object merge. I will tackle that one later. Alright. So make sure you have a minimum input of 1 and your maximum input could be as high as you want. For now I'm going to keep it at 4 because it's easy, but just make sure that if you set it to higher than 4, and every time you set it to higher, that you have all those inputs wired into the merge. Otherwise it's going to break. And let's hit accept. Let me search for the object merge that it wasn't correct yet, and then we'll be back in a bit. I know what I did. I made an example, of course, over here for the double curve in the initial one, which was something we used, but we remade this little system, and this one was still referring to the other subnet, so we don't really care about this one. So let's just delete this entire thing. There we go. Now let's go up one level. And to make sure that this save has gone through, let's select our digital asset, go to Assets, Save Asset, and save the road tool. And there we go. Well, this was the part for inside of Houdini. Now there's one thing we still need to do, and that's to make sure that our final output is also is always our output, no matter what we're doing. So let's just place an output node over here, and this means it's a really handy thing. So it doesn't matter which one I'm viewing anymore. It could be that I'm viewing merge 9, for example, but the output will always be the output node, and that's a very nice thing. Alright, one more thing, guys, which you need to remember is that Unreal, when you're using curves in Unreal, they usually have some kind of orientation attribute. And right now we're generating our own, so we don't want to use the one from Unreal. So let's place down an attribute delete. And let's make sure we have only the things we want. So we're going to delete everything except our point position. Alright, and let's save our asset again. Now, this asset is working. I'm going to add a few colors, and then I'm going to see you guys inside of Unreal. Finally, we have arrived at Unreal Engine. So I'm going to explain how Houdini Engine interacts with Unreal, and that's basically by importing whatever you use as input. So the mesh or the curve or the height field, so the terrain, or the thing you like to use as input for your asset. Then it goes for Houdini just normally, and then it imports it back into Unreal. That's a very short description, and that's what it does. Now we have imported our road tool already in here. So how you do that is just basically importing it as usual. You need to make sure that you have Unreal Engine installed, otherwise you won't see this popping up. And then when you have it installed, you can just drag it inside of your scene, and it does nothing, which makes sense because we don't have our curves turned on yet. So you need to set the input type to curve input. Let's use the top 3 ones to do this. Now we have 3 curves for our intersection. Now let's drag these along a little bit. Probably looks pretty weird in the beginning because they're all so close together. And now for the final one. Oh, a little bit too nearby still. And there we go. Let's also move them up a little bit so we can use those nice pillars we've made. With Alt drag we can create another point. And that's basically how it works. So you've got your own road tool. Thank you so much for watching. As always, we hope you enjoyed the tutorial, and if you did, make sure to follow us online for more game dev stuff. For now, this was Dokai. Bye bye.